Hi everyone, welcome back to ACER Explained. So in this series, I'm going through the ACER Practice Question booklet. So bring that up if you don't have that with you already, so that you can follow along. In this video, I'm going through Unit 3, so that's questions 9 to 11. As usual, identifying the prerequisite knowledge that you need versus the reasoning skills used, and then also looking at what bootcamp resources can help you brush up on those. Unit 3 shows us two villi in the small intestine, and it's labeled with villus cells and crypt cells, and it also gives us information about what each of those cells do. But let's focus on question 9. So question 9 is asking, if there's a net movement of water from side 1 to side 2 across a semi-permeable membrane, then what would the relevant solute or solvent concentrations be on side 1 and side 2? So this requires knowledge of osmosis. So osmosis is the movement of water across the semi-permeable membrane, and water will move up the solute concentration gradient. So what this means is that, so let's say we have side 1 here and side 2 here. So if we have, let's say, 3 particles on this side dissolved in water, and we have a lot more on this side, then water will go up the concentration gradient. So it will go where the solute is more concentrated in order to balance out the concentrations on both sides. Okay, so if we have water moving from this side to this side, that means that on this side we have less solute, and then this side we have more solute. So if there's less solute, you could also conversely say a lot of solvent concentration. So that's what it's being dissolved in. And then this side, you can say that there's lower solvent concentration. So given that, let's look at our options here. So option A says higher solute concentration and on side 1 and lower solute concentration on side 2. And this is incorrect because, as we saw here, we need to have a lower solute concentration. Okay, so we can eliminate higher solute concentration here. And we also know that we should have higher solvent concentration. So we can eliminate option D here because that says lower. Okay, so these two are technically correct for side 1, but let's look at side 2. So side 2, we know that we need to have lower solvent concentration. So this one meets that. Here we need to have higher solute concentration, and this one says lower, so we can eliminate this. So then our answer is C. You can pause this to read through the definition of osmosis here as well. Now, this question required some previous knowledge on osmosis, and it also required you to ignore irrelevant information. So there was a lot in that first sort of glance when you're looking at the stimulus. And then you get to question 9, or you get to the first question for this unit, and you realize that you actually don't need all of this information to solve question 9. You don't need any information at all. Question 9 could be a standalone question. So it's kind of balancing your time management as well. That's important that you can learn from our reasoning skills course. And the osmosis prerequisite knowledge is touched on in the content in action, renal and endocrine systems, if you would like to check that out as well. So moving on to question 10. Question 10 has given us a few diagrams as the options, the answer options, and it's asking us what the best representation of diarrhea would be. Okay, so I've kind of put these options into kind of word format. So use your booklet to follow along here. And it's saying that diarrhea, we're given this information, it's when there's increased fluidity in fecal evacuation. Okay, so let's first of all start off by drawing this diagram that we have here. So this is the lumen here, and we're kind of looking at these two villi. All right, and then we have a villus cell up here. and we have crypt cells down here. Okay, so crypt cells are responsible for transporting chloride from the interstitial fluid into the lumen. Okay, so chloride goes into the lumen. Whereas villus cells, they are responsible for transporting sodium from the lumen into the interstitial fluid. Okay, so we're starting off by basically outlining what the normal function of these cells are, okay, normally, without diarrhea. Now that we know the normal function, we want to think of what would happen in, a condition where there's diarrhea. So looking back at our concept of osmosis that we covered in the last question, we are first of all thinking of increased fluidity means that there's more H2O in the lumen, okay? Because there's blood vessels and lymph vessels here. So the H2O here, the water that's here, will go into kind of the systemic, I guess, circulation or the lymph, okay? But if the water is here, this is what's going to go into the large intestine and out as a fecal evacuation. So in diarrhea, you would have increased water in the lumen. So now looking at osmosis, we know that water follows salt. So if you have more salt, whether it's Na or Cl, it doesn't really matter. If you have more Na or Cl in the lumen, you're going to have more water in the lumen. So when there's diarrhea, you would expect there to be more sodium or chloride in the lumen. And the way that I came to this conclusion, or the way that I made that connection, was by first of all looking at the answer options. The answer options are exploring different kinds of cells, the crypt cells and the villus cells. That's why I kind of went back and looked at the normal function of a crypt cell and a villus cell, because I know that I'm going to need that information. And also I realized that the answer options were talking about movement of ions from interstitial fluid to the lumen or vice versa. Okay, so then I kind of made that connection that, oh, this is probably asking me about osmosis because it's asking me about the movement of ions and therefore the movement of water. And I can connect that to diarrhea because I can assume, even though I don't know what diarrhea is, if I didn't know, increased water in the lumen makes sense for there to be increased watery fecal evacuations. Okay, so that's kind of the reasoning behind why I'm looking at these things here and why I'm looking at sodium and chloride here. Okay, so let's look at our answer options. So first of all, we have a crypt cell, and it says that movement of chloride from the cell into the lumen is inhibited, which means that there's going to be less Cl. I love using these arrows because it makes it a lot easier for me to process. So on your little whiteboard or paper on the GAMSAT day, I would recommend drawing little arrows to help your brain. So this means that there's less Cl in the lumen, okay? Let's move on to option B. Option B, we have movement of sodium from the lumen into the cell is inhibited, which means that there's going to be a buildup in the lumen. So we can draw an arrow like that. Okay, moving on to C, we have movement of Cl from the cell into the interstitial fluid is stimulated. So the interstitial fluid is actually on this side, not here where the lumen is. So this is kind of not relevant in terms of the lumen itself. If anything, you could think that if Cl is being moved out of the crypt cell into the interstitial fluid, it might not be moving as much into the lumen. But either way, you can kind of put a question mark there because it's not talking about the lumen, and we know we want to look at the lumen. Then we have here the movement of sodium from the cell into the interstitial fluid is simulated, and that's the exact same reasoning as option C here. So we'll put a question mark there as well. We kind of already know from these two options that because we have an increase in sodium in the lumen, we're going to have an increase in H2O because in osmosis, water follows salt. We already know that B is the most viable option here. And there you go, that's question 10. Question 10 used the same osmosis prerequisite knowledge that you can find in the content in action renal and endocrine systems, but it also required your ability to pick out important information from the diagrams that were given in the answer options, as well as in the stimulus, as well as in the little text underneath there. And it also required you to be able to infer kind of what diarrhea meant and what the question was trying to ask you. And these are things that you can work on through our reasoning skills course, as well as our acceleration class on diagrams and visual stimuli. It's also something that comes with practice, the skill of inferring what the question is trying to ask. So moving on to question 11. Question 11 is asking us, what would be the most likely mechanism of action of an organism that causes diarrhea? Okay, so we know that for diarrhea, we want increased H2O in our lumen. So I'm just going to have that up there. And we have our 4 options. The first things that I look at is C and D, because we can already see the relation of chloride and Na in regards to the lumen. So don't really have to even look anywhere. We can just kind of look at C and D. So inhibiting crypt cell secretion of chloride into the lumen, which means less chloride in the lumen, means that there's going to be less water in the lumen, because water follows salt. Same thing here. It says enhancing villus cell absorption of sodium from the lumen. So you're getting rid of sodium from the lumen and putting it into villus cells, which means that there's also going to be less water in the lumen. And for diarrhea, we know that it's going to need increased water in the lumen. So we can eliminate these 2 options. Okay? Now going on to options A and B. So looking at option A, it says inhibiting osmosis via crypt cells. So we know crypt cells, they are responsible for putting Cl into the lumen. But they're not, well, this mechanism of action is not targeting this action at all. It's targeting osmosis. It's only inhibiting osmosis. Say that this organism somehow inhibits osmosis in crypt cells. Would this lead to diarrhea? You can put a question mark there, because what if, this is one of the main cells that is used for osmosis? You might not know that, right? Well, technically, every cell will undergo osmosis, because there is a semi-permeable membrane in both villus and crypt cells, and etc. So osmosis will occur in all cells. But say you didn't know this, you would put a question mark there. Then we would go on and look at option B, blocking sodium pumps of villus cells. So the villus cells, they get rid of sodium from the lumen. Okay, so if you're no longer getting rid of sodium from the lumen, there's going to be a buildup of sodium. And so if you have a buildup of sodium, you're going to have a buildup of water. And so you can pretty confidently say that B is the correct answer. So here we go. And the key here as well is that it's asking for the most likely mechanism of action as well. So looking at the 2 options, we could have been confused between A or B. The active sodium pumps are more likely to be targeted, because they are kind of an active process that's happening, and that's, you can block those pumps. How would an organism necessarily block osmosis, right? That's a little bit trickier, but that's kind of if you're really confused, and that's just another reason that B would be the right answer. So for this one, the only different thing that we really used here was adding on the process of elimination. This is a really handy reasoning skill that you'll probably use for a lot of your Section 3 GAMSAT questions. And again, the Bootcamp resources are the same as before: the renal and endocrine system, content and action for osmosis, the reasoning skills course, as well as the acceleration class on diagrams and visual stimuli. That brings us to the end of Unit 3. So like, share, and subscribe for more GAMSAT help. And we have our Instagram at ThankFlipGamSat, and our podcast, ThankFlipGamSat, Nurses Doing GAMSAT, for more GAMSAT related content. I'll see you in the next one.